In this example, I'm given a circuit and I'm specifically being asked to compute the branch currents I1, I2, and I3. There are multiple ways that we can analyze this circuit and multiple techniques. And the more techniques you learn, the more ways you can solve this circuit. So I want you to start basically by pausing and looking at the circuit and thinking what's the best analysis technique that you should be using for that particular circuit and based on that question that you're asked. So what I will do right now is I'll start comparing nodal analysis and mesh analysis. So in this particular circuit, I need to identify, if I'm to do nodal analysis, I need to identify the essential nodes. And hopefully you would agree that this here is one essential node, and this one here is one essential node, and this one here is one essential node. Okay, and of course this one and this one are the same because they're connected with a wire, and all of these here are also this, well, all of the ones at the bottom are also the same because they're connected with a wire. So technically I have 1, 2, and 3 essential nodes. So based on the general rule, I need to say out of 3, 1 will be the reference in here, and then I have to write an equation here and an equation here. But if you pay attention, if you assume that the reference node is in here, okay, you will definitely know what this voltage in here because it's based on this particular voltage source. So I have a voltage source connected between 2 essential nodes, and one of these essential nodes is a reference. So I already know that this particular V is just simply 80 volts. So I do not need to write an equation for this essential node, and of course this is a reference. So I'll end up writing just one equation in here. So if I call this one here is V1, and you write the nodal equation for that V1, and you figure out that V1, you will simply be able to figure out what the I1 is, what the I2 is, and what the I3 is. Okay, and I encourage you to do this. In this particular video, because it's part of the mesh analysis examples, I will solve it with mesh analysis, okay? But I encourage you to write the nodal equation for V1 and double check the answers I get using that. It's good training for nodal analysis. And if I were not covering mesh analysis, I would have done it with nodal analysis. So let me tell you why I would have done it with nodal analysis. Okay, so I'm going to do the same type of analysis, but now for mesh. Well, it's very obvious that we have all these windows or all these meshes. So frankly speaking, I'll have this one here. I'm going to call it, for example, maybe IA, and this one here is IB, and maybe this one here is IC, and this one here is ABCD. Okay, so we can write them that way, or maybe I can call them I1, 2, 3. It's up to you what you call them. And not only this, you're also you're also free to figure out the directions of all these currents. I just assumed them to be this way. All right, so now I'm looking at it. I have 1, 2, 3, 4. So I have, frankly speaking, I have to write 4 equations to get to the answers I want. Yeah, maybe you'll think, well, I have a current source, so maybe that will help my case a little bit. Well, and if you think about it, this current source is affected by ID and IB, so that will be a super mesh. Okay, so yeah, I might need to write super mesh in here, one mesh in here, one mesh in here, so I need to write 3 equations in order to get to the same answers. So that's why I said nodal analysis probably is a better option because I only need to write 1 equation and I'll be done. But anyway, I'll do it with mesh analysis just to show you how it would be done. And you can do it either way and you should get the answer. It's just nodal happened to be, for this particular example, this particular circuit, nodal happened to be a little bit easier or a little bit simpler. One might argue as well, if you get nodal, then you have to write KCL in here because you won't be able to figure out the current right away. But as opposed to, well, current mesh analysis will give you IC, and IC will be the same as I3 and so forth. But anyway, so let's do it with mesh analysis in here, and I'll start writing these mesh equations one by one. Okay, so here, we're going to start by mesh at IA. Okay, that simply in here is actually 30 volts plus 5 IA plus 500, and of course that will be IA, and the IA and the IB, IA is going that way, IB is going that way, so that's basically IA minus IB, and that should be equal to 0. So that's the first equation. You can move things around and you should be able to say 505 IA minus 500 IB, and I believe you need IC and ID and so forth, but they're all zeros in this particular case, and this equals negative 30. Okay, so that's the first equation. I'll just highlight it in here. So let's write the second equation. I'll go ahead and I'll write the IC because it's simpler, because this one here is a mesh current or mesh equation or super mesh. So I'm going to say, well, here's the mesh IC. So for IC, I'll get 80 volt plus 4 kilo ohms of IC minus IB. Okay, again, because IC is going upward in here and IB is going downward, so they're in opposite direction, and I believe that's it. There are 2 elements only, and that here is equal to 0. So I basically clean it. It's negative 4 IB plus 4IC equals negative 80. And that's basically the second equation. And you should pay attention to the units. Okay, so this current source is a milliamp, and everything here you will see, well, actually, I'm glad that I said that, because this is in kilo, this is in 500 ohms. So I am actually adding milliamps and amps, so I have to actually fix my equation a little bit so that everything is in there. So what I can do is I can just convert this here to kilo ohms. So this 500 and that is wrong, so I can fix them, okay, by converting this to kilo ohms, and I'll be done. Everything will be volts, milliamps, and kilo ohms. So let me just do that in here. Okay, so I'm going to clean this here. So instead of 500 and instead of that 500 in here and 5 in here. So what I will do is I'll say plus 0.5, because 500 ohms is half a kilo ohm. Okay, so now we can re-clean this here. So that will be 5.5 IA minus 0.5 IB equals negative 30, and now this equation is correct. Okay, and I don't believe anything else should be changed, because this is in milliamp, this is a milliamp, everything here we have is in, well, not milliamp, let me just pay attention. This is volt, okay, equals volt, because this is kilo ohms, and this is milliamp. This is kilo ohms and this is milliamp. This is kilo ohms and this is milliamp. Kilo ohms, milliamps, and this is in volts. Okay, so now the units are okay. All right, so move on. I believe we have this one in here. So as a reminder, so in order to write super mesh equations, what we do is we assume that this particular mesh or particular current source does not exist. So what we do is we will write this particular super mesh in here. So this is the super mesh that I should follow. Okay, so for the super mesh in here, and I just write it in here, super mesh. Okay, I'll just drag these down in here so that okay, so I'll do that in here so that I don't have to scroll up and down. Okay, so here's the super mesh equation. For the super mesh equation, again, you keep the IB, you keep the IC, you keep all the different mesh currents. They're exactly the same, and you write the equation this way. So what we have, again, I'm just going to write it so that I don't make a mistake. This is 0.5 kilo ohms, okay? All right, so what we have is the following. We're going to start with this half a kilo ohm in here, and we will say, well, that's 0.5 times, we're thinking about it from this one in here. Okay, so it's 0.5 IB minus IA, because they're in different directions. And again, I'm focusing on this particular mesh here. Okay, and then I'll move to the 4, okay, plus 4 kilo ohms, and that will be IB minus IC, because again, they're in different direction. So IB is going that way, IC is going that way, and I'm focusing on this particular mesh, so I'm assuming that the IB is the positive, so IC will be in the negative direction. Okay, and I believe that's it for this particular mesh in here, which is IB, just these two elements. So I'll have to move along in here, and I'll see that I have the 1K in here. So for this 1K, I will say plus 1 times, I believe it will be ID, and that should be 0. Okay, so that's basically the super mesh. You clean things up and you move them with a little bit of algebra. You'll get, I believe, negative 0.5 IA. I don't believe IA appears anywhere else, but the IB appears in two different places, the half a kilo ohms and the 4 kilo ohms in here. Okay, here, okay. Yeah, so I went ahead and I computed that and I cleaned it, and this is basically the equation that we get from the super mesh. Okay, so we take a look in here. What we have is we have 1, 2, 3 equations, but remember we have 4 meshes, so 4 unknowns, IA, B, C, and D. So 3 equations is not enough. So where do we get the last equation? Well, we get it from the constraint. Which constraint? Well, the constraint that is actually here. Okay, this constraint, because this particular 10 milliamp is actually affecting the ID and the IB, and we can write that constraint in here. So we can say, well, the constraint, okay, the constraint is simply that the 10 milliamp is equal to, well, as it turns out to be, the IB is going in the same direction and ID is going in the opposite direction. So that will be IB minus ID, and that will be the last equation that I have. So I have 4 equations for unknown. All I have to do is just solve them, and I'll figure out IB, IA, IB, IC, and ID, and I'll be able to figure out all the mesh currents or all the branch currents that I want. So let me just compute that for you. So after solving all these equations, you'll end up with the following values. So IA happened to be 0 amps, and IB is negative 60 milliamps, and IC is negative 80 milliamps, and ID is negative 60 milliamps. So using these mesh currents, we'll be able to figure out what I1 is, what I2, and I3. So let me just do that. Okay, so what would be I1? Well, simply I1, if you think about it in here, I1 is only affected by IA, and it's in the same direction, so it's just simply IA, which is just 0 milliamps or 0 amps. All right, what about I2 in here? So I2, you will see that I2 gets affected by IA and IB, and they're in opposite direction. So here, I2 is just simply IA minus IB. Okay, and you'll substitute the values, and that will be IA 0 minus IB happen to be negative 60, so that is simply 60 milliamps. Okay, and then I3 is simply just affected by IC. That's it, no other mesh current, and it's in the same direction. So it's just simply IC, which is negative 80 milliamps. Okay, and now we have all the currents that we want, and of course we can compute the power. For example, for the 80 volts, I know that this is 80 volts, and the current is going to the positive direction here, and it's negative 80 milliamps. You can multiply them and figure out what the power that is generated by this particular source is. Okay. So I would want you also to write, again, I would just remind you, write nodal analysis equation in here and compare the results. You should be able to figure out what that voltage in here and what the current in here and what the current in here is.